Today, we will solve for the minimum perimeter using calculus. So calculus is the mathematics of change, and one concept of calculus is optimization.
Optimization is used to determine the best or optimal value of a quantity.
Let's take a look at the problem.
The area of a triangle is 100 centimeters squared, and one of its sides is x centimeter. Find the minimum perimeter possible.
The first thing we have to do is to illustrate the problem. It says that a rectangle is 100 centimeters squared.
And it said that one of its sides is x centimeter. So since two parallel sides of the rectangle is equal, we'll label it like this and label the other two sides as y.
Since we're dealing with measurements, we can say that x and y are greater than 0.
Now let's form the equation. We know that the area is 100 centimeters squared, so we can write it as 100 is equals to xy.
Now for the equation of the perimeter, let's express it as f of x.
Knowing the formula of the perimeter being p is equals to 2 times quantity x plus y, we can write the equation as f of x is equals to 2 times quantity x plus y.
Now, since we are looking for the value of x, let's express y in terms of x.
Looking at our equation of the area, we can express y as 100 over x.
So given that, we can write the equation as f of x is equals to 2 times the quantity of x plus 100 over x.
The next thing we have to do is to get the derivative of the equation, which is f prime of x is equals to 2 times the quantity of 1 to 100 over x squared.
To find the derivative of this equation, we need to use product, addition, and quotient rule.
First, we get our first factor 2 and multiply to the derivative of x plus 100 over x.
Then we will add this to the x plus 100 over x multiplied to the derivative of 2.
Now, to solve for x, equate the derivative to 0.
Distribute the 2 so you can get 2 minus 200 over x squared.
Now, transpose negative 200 over x squared to the other side, that will give you positive 200 over x squared equals to 2.
To cancel the x squared, multiply both sides of the equation to x squared.
To get only the x squared, divide both sides by the coefficient 2.
To get the value of x from x squared, get the square root of each side. It will give us x equals to positive and negative 10.
Since we already established that 10 is greater than 0, the only value of x we can accept is positive 10.
Now, since we have our critical value as 10, we can check if it is a minimum or a maximum by checking its second derivative.
Given that our first derivative is 2 times quantity 1 minus 100 over x squared, we can get our second derivative as 400 over x cubed.
Since it is greater than 0, then we can say that if we graph it, it will be concaved up. Therefore, it is a minimum.
So now, our x is equals to 10, and to get y, let's substitute 10 to its equation. That will give us 100 over 10, which is equals to 10.
Now that we have the value of x and y, we will go back to our equation for the perimeter and solve it using these values.
Knowing that x and y is equals to 10, then our perimeter is 2 times the quantity of 10 plus 10, that gives us 40.
Therefore, the minimum perimeter of the rectangle is 40 centimeters.
This basic knowledge can be very helpful in the field of architecture.
In architecture, optimization can help in minimizing the amount of materials needed for buildings and other structures.
And that's it. I hope this has been helpful for you. Thank you and have a good day. Don't forget to give a thumbs up and subscribe our channel. Thank you.